All right, so we are done with describing a data center. So everything we talked about up until now, or recently, was about giving numbers that describe where typical data values are. So now we're going to describe several common numbers used to measure the variation of a data set. So typical ways to measure how spread out data are, in other words, include the range, standard deviation, and variance. So these are three common ways to describe how spread out data are. So the simplest way to describe how spread out data are is with the range. So the range is the distance between the minimum data value and the maximum data value. So in other words, the range is the max minus the min. So let's go back to men's heights. If the tallest man in the world is 8 feet tall, the shortest man in the world is 1 foot tall, the range would be 7 feet. So it's a very simple, crude way to describe how spread out data are. So the range for men's heights is 7 feet, meaning that all men's heights are spread out over a distance of 7 feet. So, all right. The standard deviation. So the standard deviation is a number that describes about how far data values are from the mean. I say that we have a formula to compute it, but computing the standard deviation is far less important to us than understanding how to use it. So here's the thing. The standard deviation is this complicated looking thing involving this complicated formula. The thing is, you don't want to get too hung up on the number crunching. Yes, you want to be able to calculate a standard deviation by hand, but it's far more important for us to understand what that number is giving us. So we have two formulas for the standard deviation. One formula is the sample standard deviation. The other formula is for the population standard deviation. So again, let's go back to men's heights. If you grabbed every man in the world and recorded his height, well, you could use this formula to describe how spread out men's heights are. So this formula is saying what you got to do is you got to take every man in the world. You got to subtract the mean height of every man in the world, the population mean. Then you got to square it. So you have to do that with every man. Take every man's height, subtract the population mean from it, or the average height of all men, square it, and then you have to do that with every man, add them all up. Then you got to divide by the total number of men in the world. So maybe that's 3.5 billion. After you do that, you got to take the square root of it. So, I write down here that note that computing the population standard deviation requires you to have measured every member of the population. So we won't actually be computing this number ever. So we are more interested in trying to approximate this number. So that's what statistics is all about. So in reality, we will never be able to find the population standard deviation of heights of all men. We're only going to be able to estimate it. So one way we could estimate it is by taking a sample. So maybe we could grab 40 men's heights, and we could find the standard deviation for those 40 men. In other words, we'd be finding a sample standard deviation. So the way you do that is you take each of your 40 men's heights, you subtract the sample mean from them, you square it, you add up all those numbers, and you divide by n minus 1. So if we grabbed 40 men, we would be dividing by 40 minus 1. And after that, you take the square root of the whole thing. So the sample standard deviation gives an estimate of the population standard deviation. Again, so we're going to use these formulas. It's going to spit out a number. That number will help describe how spread out men's heights are. All right, so let's work an example. So, all right. So suppose 3 men's heights are recorded in inches. So you take a very small sample. You only grab 3 men. And this produces the following numbers: 57, 58, 59 in inches. And I ask, well, what's the sample standard deviation? Okay, so to find the sample standard deviation, we have to use our formula here. Sample standard deviation equals the sum of our data values minus the mean squared, add them all up, divide by the number of data values minus 1, take the square root. So in order to find our sample standard deviation, well, we're first going to need this number. We're first going to need the sample mean, or in other words, our x bar. All right, well, how do we find our x bar? Well, it's just the average. So to find our x bar, you're going to do 57 plus 58 plus 59 divided by 3. If you do that, you will get 58 inches. So that is the average height of our men in our sample, or in other words, our sample mean. All right, now to find the sample standard deviation, our S, well, according to our formula, we're supposed to take the square root of a whole bunch of stuff. What we're supposed to do is take each data value, subtract the mean from it, square it, add it up. So our first data value is 57. So we're supposed to take 57, subtract 58, then square it. Then we're supposed to move on to our next data value, which is 58. So we're supposed to do 58 minus the mean, 58, square it. Then we're supposed to take the next data value, which is 59. So we do 59 minus 58, then we square it. And then, after that, we're supposed to divide by n minus 1, where n is our sample size. So we grab 3 men, so that's our little n, and we're supposed to subtract 1 from it. Now, if you crunch this number, you get a sample standard deviation of 1 inch. And so what this number tells us is this number is describing to us about how spread out men's heights are in the sample. So if we look at our data, we see, oh, men's heights. Well, they're not spread out very much. The standard deviation is 1 inch. So the standard deviation is telling us that typical men, their heights are about 1 inch away from the mean. That's what the standard deviation is telling us. So you have to be able to understand formulas using summation notation and all that stuff. And you have to be able to find standard deviations by hand. In the future, we're going to have some formulas where, yeah, I mean, you're forced to do it. Now, you do have a calculator. So your calculator can find standard deviations for you. So on your Chapter 3 homework, you're going to have to find a whole bunch of standard deviations. What you should do is do a few of them and make sure you can use the formula if need be, because we're going to have some complicated formulas later on. But after you've got the hang of it, you should just use your calculator to find your standard deviations. So you don't want to waste your time.